Hello, welcome back. We have another motion with constant acceleration problem that involves two cars and a chase. This one's actually a little more challenging to think about. None of it's hard, none of it's difficult calculationally, but to understand how to go about it, you have to think a little bit. So what we have is one car follows another car on a road. The lead car has a velocity of 25 meters per second, and the trailing car has a velocity of 30 meters per second. When the cars are 40 meters apart, the front car hits the brakes with a negative acceleration, negative 2.0 meters per second squared. That's the acceleration when the front car slams on the brakes. Okay, three questions. Part A, how long does it take for the lead car to come to a stop in seconds? Part B, the chase car hits the brakes at some time, or hit the brakes at the same time as the lead car. What minimum acceleration is needed to not hit the lead car? In other words, to avoid a collision, right? And then part C, how long does it take for the chase car to stop in seconds? So there's three parts to it, and you always need to tackle part A before B, before C, because if you try to do it all at once in your brain, you're going to probably not exactly know what to do. But we do need to think a little bit about what's going here. We've all been on the freeway, and we've all been following cars in front of us. So in this situation, we know that the front car in front of me is actually going slower than I am. So I'm creeping up on this person because he's only going 25 and I'm going 30. So I'm actually, if we're both going down the road, I'm actually very gently creeping up on his bumper. But at the moment when I'm 40 meters away from this guy's back bumper, the front guy hits the brakes hard, negative 2.0 meter per second acceleration. And he brakes all the way to a halt. Like there's a cow in the road. He goes all the way from 25 meters per second to 0. That's what it's basically telling you. He brakes to a halt at that acceleration. So what we want to do is first draw the situation. That's essentially the situation there. Part A is how long does it take this guy to come to a halt. Part B is how hard does the car behind him have to brake in order to avoid a collision. So we need to draw it out so that we can see what constraints are going to basically dictate what equations we need to use. So the first thing we're going to do is we're going to say that we're going to draw the picture like this. Well, you can do it however you like, but this is what I did. So I'm going to basically say this is time, or I should say x is equal to 0 position, right? And I'm going to draw a couple of cars. So I have a front car, a lead car. I'm going to call this lead car car A. And then there's a trailing car. I'm going to call this guy car B. Right? Now, what is car A's velocity? Car A's velocity from the problem, 25 meters per second. Right? And what is the distance between the cars when the braking happens, when the front car hits the brakes? It tells us that. So it tells us that it's 40 meters. So another way you can look at it is say, well, I'm going to say, now there's always a little issue in physics because it says that, it says right here, when the cars are 40 meters apart. Okay, that really means that it's basically front bumper of this car to back bumper of this one's 40 meters. But in physics, I mean, these cars I'm drawing as these blocks that have width. I mean, you want to basically pretend that they're little points going down the road, that they're really dots with no dimension. Because if you were going to take into account the width, the length of the car, then you'd have to know, well, they would have to tell you what the length of the car is, right? But instead, it just tells you how far apart the cars are. So the way I'm going to do it here is I'm going to say that this position here when the action starts to happen is 40 meters. When this car is 40 meters ahead of this one, but of course, if this car has some length to it, so of course the collision is really going to be less than 40 meters. But if we take the cars to be these tiny little dots, then really they're 40 meters apart. So if you want to just be explicit, you could